Okay, that titration, right? So if you monitor the history, then you get a titration curve similar to ethylene-based titration. Instead of monitoring H+, then you monitor the calcium 2+ activities. So this, if you use a pH meter with a calcium selective electrode, then you can construct this history titration curve. So it's P calcium versus EDTA added. So nothing new here. Okay, so before the endpoint, your knowledge tells you you're going to have excess calcium. And then at the end point, you have 0 calcium, but then the calcium is going to come from the complex dissociation, the reverse. Because you're monitoring the peak calcium, so it's a continuous deal. So at every single point, there's a quantity of calcium. So you cannot say that 0, 0, there will be no calculation, right? And therefore, here, the calculation is the one we have gone through, okay? But I will review with you once again here, which is a more challenging one. Now, after the endpoint, we have excess EDTA. So in each region, we are talking about equilibrium calculation. So be sure you understand that, even though this is excess, then it still participate in the equilibrium calculation for calcium. So envision this titration, right? So let's say the condition you need to add ammonium-ammonia buffer, which is what you will be doing today. So it's maintained at pH 10. Okay, then your knowledge, Kf is right there, then you titrate. Let's say EDTA is 0.1 molar. Okay, then you use a calcium electrode to sense the activity of calcium. Then for the calcium is 10 times lower concentration, 50 mil of this. So you can plot the titration curve, the history. But if I ask you to calculate, then here will be the calculation. So instead of using pH meter, you calculate, or you can calculate to verify the titration curve. Okay, before you add any EDTA, be sure you know how to calculate the peak calcium, right? Which is a piece of cake. Before you add anything, you are looking at it, it's the concentration right there. So the concentration 10 to the minus 2, and therefore peak calcium is equal to 2, right? No volume need to be considered. Concentration is concentration, right? Don't divide that by 50 mil. That would confuse you and give you the wrong answer. Any question with that? Okay, now you add, once you add EDTA. So, for example, add 2.5 mil of EDTA, so that will be before the endpoint. Before the endpoint, you still need to calculate the excess calcium, so because peak calcium based on this concentration. So the calculation will be straightforward for that because we've gone through that earlier. So all you need to know is the initial total of calcium minus the quantity of calcium reacted with your EDTA. Now, because the Kf is large, right? So the reaction here is complete, okay, to the right. So the limiting agent being the EDTA, right? Before the endpoint, the EDTA is limiting, so whatever the quantity of EDTA added. So the scanner did not show the part here, so this is simply MV, so it is M for EDTA, V is 2.5. Okay, MV, EDTA. Here, the MV for the initial calcium quantity, and take the difference. okay, then over the mixture volume. So this is your concentration of the excess calcium, the excess calcium. So change that into this unit, then 2.32. So within this region, the calculation will be like this. Do you have any question? So follow me, I go slowly, line by line. So as I talk about that, beneficially for you is that you write down whatever, rather than you proceed and just copy and not knowing what's been discussed previously. So are you all okay here? Now we come to at the end point, right? So at the end point, you compare the number of moles. So it turns out that once you add 5 mil, then that is the end point, because the equal number of moles react. So that is the end point. So it's all calcium complex. So the concentration is going to be all the calcium change into the complex. So the MV for the original calcium, all of it change into complex. So total volume, then this is the concentration for the complex. But then P calcium is based on how much of free calcium in a mixture. Is not a measurement of that, but although you will need this information to calculate for this concentration. Okay, so now go back to what we learned earlier. Then you do the alpha 4 calculation, page 10, then you calculate this, do this as an exercise at home. So there's an exercise. Then it should give you this number, 0.425.
And that's the amount of free calcium.
The alpha 4. Alpha 4, we will need that.
Oh,
This is
okay.
alpha 4 alone. We will need this information in order to proceed, calculate for free calcium. So which will be next.